All right, so let's take some concepts that we've talked about in previous science courses and you may know a little bit about, but let's kind of look at the chemistry as to why they happen. So today's lesson is going to be on solutions. And you may remember from previous science courses, we have two types of solutions. We have solutions which we call homogeneous, and we have solutions which we call heterogeneous. So a homogeneous solution or mixture, let's add in the term mixture, okay? It is a solution, it's a mixture, and this means that it is evenly mixed. So if we have a homogeneous mixture, something that's evenly mixed together, like maybe, let's say, sugar water. When you take a sip of sugar water, it tastes the same. And if you take a second sip of sugar water, it tastes the same, right? It's evenly mixed together. A heterogeneous mixture, this is going to be unevenly mixed. Okay, so an example of a heterogeneous mixture that you may have talked about in a previous science course is, say, orange juice with pulp. So when you take a sip of orange juice with the pulp, you may get more pulp in the first sip than you do the second sip, or vice versa. So what actually causes something to be mixed homogeneously or heterogeneously? And the reason this happens, it is going to be determined by the intermolecular forces. So the chemistry behind these different types of mixtures are, what are their intermolecular forces? So in a homogeneous mixture, both are going to have similar intermolecular forces. All right, so for example, our gases. Gases have similar intermolecular forces. And this is why the air that we breathe is going to be a homogeneous mixture, so it doesn't matter which classroom in the school you go into, the air is there, you're able to breathe it, and it works out well for us, right? So gases have similar intermolecular forces. Another example, let's look at sodium chloride and water. So sodium chloride is an ion. Water is a dipole. It does also have hydrogen bonding as well, but when we look at this and we dissolve sodium chloride in the water, why does sodium chloride break apart into its two ions? So let's start with water. Well, no, I'll just leave it. Okay. Okay, so we know that oxygen is a partial negative and each hydrogen is a partial positive. So what we see here is an attraction between this partial negative and the positive cation of the sodium. And this partial negative of the, partial positive of the hydrogen is attracted to the negative in that chloride. All right, so what we end up with here is a ion dipole moment. All right, so this water is a dipole, and both of these ions are being attracted to the dipole, so we end up with this ion dipole. And so their intermolecular forces are similar enough that they are able to form this ion dipole, and therefore sodium chloride will dissolve in water, all right, to create a homogeneous mixture. A heterogeneous mixture is going to be formed when both substances have different intermolecular forces. All right. Now, these are very different intermolecular forces. All right. So above in our homogeneous, an ion and the dipole, these are technically different, but they create that ion dipole. All right. So it is still a homogeneous. So when we say they have different, we're talking about very different. Okay. And the example for this is going to be oil and water. We know that oil is nonpolar, water is polar. Nonpolar and polar are unable to dissolve in each other. They have significantly different intermolecular forces. Two other terms, a colloid. A colloid is a type of heterogeneous mixture. All right, and a colloid is going to display the Tyndall effect. And the Tyndall effect is the ability to scatter light. So some examples of a colloid are going to be fog and milk. These are both heterogeneous mixtures. All right, and they are colloids. Now, fog. When you're driving and it's foggy out, you learned in driver's ed that you always drive with your low beams on, never the high beams when it's foggy out. Why? Now, you don't want to do this while you're driving, but when you are parked in your driveway before you go somewhere, if it's foggy, just take a minute, you turn on the bright beams and look at how much different it looks. Put them back on the low beam and you'll notice you can actually see better with the low beams on because fog is a colloid and it scatters the light. Now, of course, you're not going to drive with your high beams on, and don't try that experiment while you are driving. That is completely unsafe. All right? But it scatters the light, making the high beams so much more bright, and you just cannot see. The final type of mixture is going to be a suspension. And this is also a heterogeneous. And this is when we have large particles which are suspended in a substance. So you have large particles suspended in a substance, and if you let it sit, they will settle out. And an example of this would be muddy water. If you were to go out to the creek or the lake and get some muddy water, put it in a jar and let it sit, the mud will eventually settle down to the bottom, and the water will be the rest of the container. All right, so that is a suspension. A lot of medications will say shake well before using, and the reason it tells you to do that is because that medication is a suspension. You need to make sure that you shake that well before using, because if you don't, then what you end up with is an uneven dosage of that medication. You're going to get too much or not enough, and that can be very problematic. So anytime you have something that says shake well before using, you need to do so because it is in fact a suspension.